Hey, how's it going, everybody? Welcome back to another video. Hope you're having a great day. And today we're going to be doing another LeetCode problem. So let's take a look at the problem here. It states, well, it's called generate parentheses, and it's a LeetCode medium. And it says, given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. For example, given n equals 3, a solution set is the following. And it looks like to me there are two cases here that are legal parentheses. And they are, for every right parentheses, you need to have a left parentheses and vice versa. And you can never have more right parentheses than left parentheses at any given time. So how do you approach this problem here? Well, when I look at the prompt here, I see the word combinations, and I'm like, okay, this is going to be a combination or permutation type problem, which usually involves recursion. Now, any problem that you can do recursively, you can do iteratively, and that's something that you should state to your interviewer. Usually with like a combination solution, a recursive solution is going to be more elegant. However, the trade-offs are that you are going to have the overhead of using the call stack, as well as the potential of a stack overflow. So if we want to do this recursively, the best way to diagram this is with a recursion tree, and that's what we're going to do next. All right, so for this example, let's assume that our n equals 2. So we can have 2 left and 2 right parentheses. So in order to generate this, what we want to do is we want to start out with an empty string. So let's go ahead and just write an empty string here. So at this point, we can do one of two things. We can either add an open parentheses or a closed parentheses. So let's say we recurse once and we add an open parentheses. Okay, that's legal. But if we want to add a right parentheses, we've broken our constraint because we don't have a left parentheses to match it up against. So we won't draw that. Next, we come down here. We go ahead and we add another open parentheses, and that's legal. And then we can also add a closed parentheses because that's also legal. Next, we come down here. We have these two open parentheses. We can't add another one because remember our limit is 2, so we can't add another open parentheses. However, we can add a closed parentheses. Next, we come over here and we can go ahead and add an open parentheses. However, we can't add a closed parentheses because then we'll have more closed parentheses than open parentheses. Next, we come down here. We see that we can't add an open parentheses because we already have 2. We can add a closed parentheses. Next, we draw this one, and we can't add an open parentheses because we already have 2. However, we can add a closed parentheses. And since on both of these we're done, we can go ahead and add them to the list that we have. So this would be our solution for n equals 2. So what is our time and space complexity here? Well, we see that for every string that we have, we can either add an open parentheses or a closed parentheses, which means that for every call or every time we go down this recursion tree, we are growing by double. So our time complexity here would be 2 to the n. And then since we are doing this recursively, every call here is taking up space. So again, our space complexity would also be 2 to the n. All right, now that we went ahead and diagrammed it, let's go ahead and see what the code for this would look like. So let me actually make this a little bit bigger. All right, so we know that it's going to be returning a list of strings. So let's go ahead and create that now. And let's call it result. We know that we're going to need a helper function that we're going to be using to recurse. So let's go ahead and call that helper. And for now, we don't know what's going to be passed, so let's leave that blank. And then finally, we're going to be returning the result. Okay, so let's go ahead and code out our helper function. We can go ahead and make it private. It's not going to be returning anything, so we'll have it as void. And it's going to be called helper. All right, so the things that we need here are going to be the result. So let's go ahead and add that. So we have result. we know that we want to have the string that we're generating. So we'll just have string and then we'll call it cur. And then we know we're going to need the amount of left parentheses and right parentheses we have remaining. Alright, so let's go ahead and give our base cases. So the first case is going to be when the string that we have is illegal. So there are two ways that this can happen. The first is if our left parentheses ever is less than 0, or if the left parentheses that we have left is ever greater than the right parentheses that we have left. And if we have that, then we'll just go ahead and return. The other case is when we actually want to add the string to the list. So if we ever get to left equals 0 and right equals 0, then we want to go ahead and add it to our list and then return. So we'll do result.add cur and then return. And finally, we have the two cases where we're actually going to be recursing. So the first case is when we're adding the open parentheses. So it's going to be cur plus open parentheses. And then we're going to decrement left by 1. The second case is for the adding the right parentheses. And in this case, it's going to be right minus 1. All right, so let's go ahead and run that. And as you can see, we forgot to add it initially. So let's go ahead and do that now. So we have result. Initially, we're going to have an empty string. And then we're going to have n and n for our left and right parentheses. So let's go ahead and try that. And we see that we have a success here. So for the runtime, it's going to be 93%, which is pretty good. And then memory usage, 100%, which obviously is very good. So that's going to be all for this video. I hope you guys enjoyed it. Please go ahead and hit that like button. Please subscribe if you haven't. I do a lot of these types of videos, just anything like tech related. So it would be really helpful if you guys did subscribe. So yeah, that's going to be all. We'll see you guys next time. Thank you for watching and have a great day.